Okay, let's move along to polygons, regular polygons. Closed figures with all sides of equal length and all interior angles equal. Okay, so these are the keys for regular polygons. Sides of equal length and all interior angles being equal. Well, of course, if all interior angles are equal, all exterior angles are also equal. But we're more interested in the interior. Now, what we can do, if we want to find the perimeter and area of shapes of these polygons, what we can do is we can locate the center of the polygons, and then we can draw triangles by joining the center to, and this is going to be tough to see, but I'll try to make it a little bit, there we go, by joining the center to the vertices. And notice that as I go around this is the pentagon, the five-sided figure. If I go around here, notice that I'm able to form 5 triangles, 5 isosceles triangles. And they're isosceles because this shape, or this length, is the same as this length, which is the same as this length, because they're all from the center to each of the vertices. And now there's another distance here that we can look at, and that is this, and I'll distinguish it by using a dashed line. This is called the apothem, and this is a perpendicular from the center of the figure to the middle of one of the sides. So that's a right angle there. And that apothem happens to be, as it turns out, the height of the triangle that I've drawn. And we could draw apothems or apotha. I don't know what the plural for apothem is, probably apothems. I could draw those for each of the triangles, but I don't really need to because I know that that distance is going to be the same as this one for each of those triangles. And so that's the height of each of the triangles. If I were to know this side length here, I could calculate the perimeter by adding side plus side plus side plus side plus side, which is pretty interesting. Well, not really interesting, I suppose, but that's just straightforward. So the perimeter, I'll go back to my pencil here. So the perimeter, and actually, sorry, but just before I do that one, if I were to do the same thing for this hexagon, which is the 6-sided figure here, again, forming, I won't form all of them in this case because you basically know what's going to happen. I'll just form a couple of them. So I could draw these isosceles triangles here. Again, drop a perpendicular from the center to one of the sides. In this case, I'll do this side. That's a perpendicular. That's a right angle right here. That is that apothem, which is the height of that isosceles triangle. Again, we've got these side lengths all the way around. Okay, so the perimeter is, in this case, for the pentagon, the perimeter is 5s. For the hexagon, the perimeter is 6s. So if the number of sides of a polygon were, say, some unknown value, or just in general, n, for a number of sides, I could say the perimeter is n times s, where n is the number of sides and s is the side length. Now when we come to the area, we can simplify the area a little bit, and I'll just use this one as an example. We could use the pentagon also, but I'll just look at the hexagon here. The area of inside a hexagon, we see that there's going to be 1, 2, 3, 4, 5, 6 triangles, and each triangle, so the area of a triangle, as we saw above, is base times height divided by 2. Well, the base is the side length, so I'm going to say s, and the height is the apothem, divided by 2. Now, I know there are 6 triangles that form this hexagon. And so the area of the hexagon, actually maybe I'll put this down here, area of the hexagon in this case, is going to be the number of triangles, which in this case is 6, but in general it would be n, times s times a divided by 2. Okay, so this is the area of each individual triangle, which is then right here. And the area of the shape itself, the polygon, is the number of sides, or the number of triangles, times the area of each one. Now, if I know the side length, if I know there are 6 side lengths that form the base of each of those triangles, there are 6 side lengths that will form the perimeter, then notice here that I've got the perimeter is n times s, and here I've got an n times s here in the area. So I can simplify the area to be the perimeter times the apothem divided by 2. So if I'm given one of the side lengths for any polygon, any regular polygon that we have, here is a pentagon with 5 sides, a hexagon with 6 sides. If I know the perimeter, if I know one of the side lengths, and I know the number of sides, I can find the perimeter. Then if I have the apothem, I just multiply the perimeter times the apothem and divide by 2, and that gives me the area of that polygon without calculating each individual area of each individual triangle and then multiplying by 6, for example, in this case. So the formula for perimeter is number of sides times the side length, and the area of each polygon, a regular polygon, is the perimeter times the apothem divided by 2. Okay, so we're going to look at a couple examples in a second, so keep that sheet handy. And we're going to now look at some common figures with their areas and perimeters. So a square is 4 times s for the perimeter, and s squared, also as we might have seen from the Pythagorean theorem from a day or two ago. Here is the perimeter of the rectangle. We've got a length and a width. We see there's another length and another width, and the perimeter just is tracing around the outside of the shape. So we look at one length, a second length, one width, and a second width. So length plus width plus width. So we've got length plus width twice. So that gives us the perimeter of a rectangle, and then the area is length times width. A square is the same as a rectangle, just a special type of rectangle where the length and width are both the same side the same length, and we call them side length s. Then we go on to the triangle, which we've already seen. The perimeter is just the side lengths added up, side 1 plus side 2 plus side 3, and the area is base times height divided by 2. And then for a circle, the perimeter of a circle has a special name called the circumference, and the circumference is 2 pi r, or it can also be written as pi d, because 2 times the radius is the diameter. So 2 pi r is the same as pi d, because if we take the 2 from here and the r from there, we know that it's d, the pi gets carried over, so pi d is the circumference of a circle, and the area of a circle is pi r squared. So for the circumference of a circle, we can either use the diameter or the radius. However, for the area, we have to use the radius. Okay.